Hello everybody and welcome back. We're going to continue our exploration of the 2014 Canadian Senior Mathematics Contest paper. We've done questions 1 through 4, now it's time for question number 5. And just like the last question, it's sort of scary. It looks like it's got functions in it, but we'll get to that in a moment. Let's read the question. Determine all real numbers x for which the cubed root of 2 plus x squared plus 3 times the cubed root of 2 minus x squared is equal to 4 times the cubed root of 4 minus x squared. Wow, that looks complicated, especially with all those cubed roots in there. I don't like them. The cubed root is not nice to manage. Okay. So this question, if I were doing it, if I were in high school, I could very well have skipped this question. It looks scary. It really does. Because you can't add cubed roots, so, I mean, that's nonsense. But if we inspect things a little closer, and if we have some wisdom under our belts, you know, if you're very involved in math enrichment, you might this might pop out to you, or if you've just done years of math. That's certainly possible. Or if you're a beginner, you can take what you learn from what I'm about to say and apply it in the future. But we stop and we look and we say, okay, well, this is a bunch of scariness and a 2 plus x. And this is 3 times a bunch of scariness, really, really awful stuff, and a 2 minus x. And this is 4 times some scariness and a 4 minus x squared. 2 plus x, 2 minus x, and 4 minus x squared, they share a special relationship. This is a difference of squares. 4 minus x squared factors into 2 plus x times 2 minus x. Okay, and that might give us an angle of approach. Because what we might do is we might say, well, this stuff here, it's scary. Let's just call him A. This stuff here is scary. We'll call him B. We can likely get a relationship between A, B, and this scary stuff over here that we might call C. So I'll show you what I mean as we try and solve this question. So, what are we trying to do? Always a good idea to write it down to refresh our memories. 2 plus x squared, and then 2 minus x, still got that squared, equals 4 cubed root of 4 minus x squared. So I would say the big key to doing this question is to realize that 4 minus x squared is the same as 2 plus x times 2 minus x. Okay, that's the sort of stuff you have to look for. Questions like this, they got functions in them, weird functions like cubed roots, weird functions like logarithms, those are also scary. But you got to look past them. You got to get over your fear, look past them, and try and find other relations that you can work with. So in this case, we have one right here. Now, it's not readily accessible. I mean, we've got this square here, and this cube root, and this cube root. But if we were to, give this guy a name, let's rewrite it here. Cubed root of something squared is the same as raising something to the 2/3. Okay, this is exponential manipulation. Like you can manipulate the exponents. Cubed root, that's the same as saying to the power of 1/3. And then at that point, you can do product of exponents. And so now these aren't looking as scary. I mean, fractions in the exponent is bad, but somehow the cube root symbol looks more terrifying. Okay. So what I'm going to do is I'm going to say let a equal 2 plus x to the 1/3 and b equal 2 minus x to the 1/3. So this, we take out the factor, the exponent of 2, we get a squared plus 3b squared is equal to 4ab. Right? Both of them are raised to the 1/3, so that can come out in common. And the product, as we've already noted, is going to be exactly 4 minus x squared. So we really do get this equation. And finding a's and b's that satisfy this is so much easier. It really is. Okay. And then once we have an a value, we raise it to the power of 3. We subtract off 2, we've got our x value. Okay? So what can we do? What can we do? Well, what we can do is we can say, well, we got an a squared, we got a b squared. Admittedly, we've got a bunch of b squareds. And we have 4ab. So a squareds, b squareds, and ab's, that brings to mind something else. We've got difference of squares up here. What about just, a plus b squared, that sort of stuff? So we know that a squared plus 4ab plus, minus 4ab plus 4b squared is the same as a minus 2b all squared. That's something we can stop and we can notice, and that's very similar to what we've got up here. So we rearrange this equation here. We're trying to fit it into this. Well, we don't have enough b squareds. What we can do is we can add and subtract 1. So we added a b squared onto here so that we get this relationship. We subtracted off a b squared to keep everything balanced. Okay. So then a minus 2b squared minus b squared is equal to 0. Or we can say a minus 2b squared is equal to b squared. Well, that's fantastic. We're starting to get stuff, because now that we have these as squareds, what we can do is square root both sides and we get 2 relationships. Square root both sides. We have to have a plus minus in there somewhere. We get a minus 2b equals plus or minus b. So we get 2 cases for a relationship between a and b. So we can either have a equals b, or we can have a equals 3b. These are the 2 possibilities we could have. So here's a over here, here's b over here. We could substitute these back in. A equals b. Let's take a look at that one. We'll start on the next page. I'm doing this one first because he's easier. So what does that mean? That means 2 plus x to the 1/3 is equal to 2 minus x to the 1/3. If we raise both of those to the 3rd power, we get 2 plus x equals 2 minus x, and we can work that out to be x equals 0. Okay? And we could double check that this satisfies the relationship that we want, but we don't need to. Okay. We can do that a little later. We can instead now suppose our other condition. So we had a equals b, so we could check a equals 3b. So what were a and b again? We substitute those guys back in. 1 over 2 plus x to the 1/3. We get 3 here, 2 minus x to the 1/3. Raising both sides to the power of 3. We get 2 plus x on this side. We need 3 to the power of 3, so that's 27. And 2 minus x. Okay? So we can rearrange that. We can get x is equal to, we can bring the 2 over. That should be 27 times 2, which is 54, minus 2. We bring that over to that side, so 28x is equal to 52. So x is going to be 13 over 7. Okay, we can work that out, just calculator manipulation, but we don't want to take too long, write down all our steps. We don't need to. It's the 5-mark question. So there's not a whole lot of room for getting part marks. Okay. So we worked that out. We got x is equal to 13 over 7, x equals 0. Now, was there any other cases we could handle? Any other way we could approach this? Well, there's probably other ways we can approach this. But look at the way we did it. You know, very methodical. We got rid of the scary parts. Turned them into just harmless variables, a and b. And we said we'll come back to them later when they're in a more manageable expression. This is not an easy expression to deal with. Okay, we got it to this point. We noticed the similarity with a minus 2b squared. So we said, okay, that's what we're going to shoot for. And we were able to work it out and get very nice relationships of a expressed in terms of b. So we got our solutions. So x is equal to 0 or 13 over 7. And if we were still not convinced, I mean, this 13 over 7, he just sort of pops out of there. What we could do is we could double check. We could go in and work this stuff out. We could say, okay, well, and 0 is not hard to check because we're getting cube root of 4 plus 3 times the cube root of 4 is equal to 4 times the cube root of 4. That one's not that hard, but check x equals 13 over 7. That's the weird one. There's sort of no rhyme or reason why 13 over 7 should work. So cube root of 2 minus 13 over 7 squared plus 3 times the cube root of, sorry, that's 2 plus, and this is 2 minus. Right, we can start manipulating that. We can figure this one out. This is 2, so that's going to be 27 over 7 raised to the 2 over 3 plus 3 times 1 over 7 raised to the 2 over 3. Okay. So this 27 comes out. And we'd get 27 to the 2 over 3, so that's 9. 1 over 7 to the 2 over 3, plus 3, 1 over 7 to the 2 over 3, so that's 12. 1 over 7 to the power of 2 over 3. Okay. So that's the one hand. So that's the left-hand side. What's the right-hand side supposed to be? Well, that's going to be 4 times cubed root of 4 minus x squared. 4, and then we cube root of, so what is 13 divided by 7 squared? Well, that's going to be 4 minus 169 over 49. Okay. And then we can do 196 over 49 minus 169 over 49 to the 1/3. Okay, so that's equal to 4, and then 27 over 49 to the 1/3. Well, the 27 pops out, becomes a 12, and then it's 1 over 49 to the 1/3. Well, that's just 7 squared, so we get 12, 1 over 7 to the 2/3. So this one does indeed work. As I said, the 0 case is very easy to verify, and if you're confident in your work or you really just don't care, I mean, the 5-mark questions, maybe you want to get to the 10-mark questions, at this point up here where you said x equals 0 or 13 over 7, you could be done. But for me, the 13 over 7 stands out. It looks a little odd. The math tells me I'm right, but I've been wrong before. You can look at other videos where you can see me screwing up. So I wanted to double check the 13 over 7. So I plugged it all in and I worked it out. And the left-hand side was equal to the right-hand side. So that concludes question number 5. It looked scary, especially with those cube root symbols. Somehow cube root is scarier than to the 1/3, but that's just me. And we got all real values x that worked. Very methodical, clean way. All we had to do was just sort of disguise the parts we didn't like as harmless variables a and b. But we can definitely see the caliber of questions being raised. I expect question number 6 to be even harder, but we'll tackle that together in another video. So thank you so much for watching.